This is the University of St. Lasal College of Arts and Sciences Mathematics Department. Another one for our Algebra 101. This is after the operations of functions, and this will be composition of functions. Okay, so we will try to compose functions here in this lesson, but before we go there, let's have some prerequisites first. Okay, so um, in our videos in evaluation until in our in our operations of functions, I've only been evaluating numbers. Okay, there, especially in our evaluation of functions, so we're only evaluating numbers there until you can simplify things to the most simplified level. Also in our operations of functions, there's only an x here. I haven't I haven't let you evaluate and operate at the same time. But nonetheless, we're going to have it here composition. So before that, prerequisite is we're going to evaluate functions with variables. So given, for example, we have f of x equals x squared plus 1, we will try to evaluate or substitute the values of all the x's here, not by a number, not by a fraction or any sort of that. We're going to evaluate it with another variable, say. Okay, so let's try to evaluate. So what is f of a? That's the question here actually. So f of a is simply all the x's here in this part will become a. Okay, so simply put, f of a is equal to a squared plus 1. Okay, all the x's becomes a because we will evaluate at a. So that will be our answer. Okay, so there will be no single number answer here. There will be no numbers wherein we're going to combine them, but we can combine variables. The same thing we did in our operations of functions. It's when we combine and simplify things until we cannot simplify anymore. And that will be our final answer. Also in this lesson. Okay, more. Let's try to evaluate x as z. So the same thing happened here. All the x's will become z. So f of z is z squared plus 1 is equal to z squared plus 1. Okay, so clearly enough, all the x's becomes that variable. Okay, how about this? Let's substitute it or evaluate it at a plus 1. Okay, so all x's in this form, f of x equals x squared plus 1, this particular x will become a plus 1. So if that happens, imagine this x here will become a plus 1. That will be this. Okay, so f of a plus 1 is equal to a plus 1 quantity squared. A plus 1, that's part of the original function, so we need to copy that. Okay, so from here, we will try to simplify things. This is a plus 1 squared, so remember our factorization. So a, the first term will be a squared, the middle term will be 2 times a times 1, that's 2a. The third term will be 1 squared, that's going to be just 1. So we will have a squared plus 2a plus 1. This plus 1 came from here, so we didn't do anything about that. And then we'll try to combine terms. So you can combine a squared and 2a, clearly. So a squared plus 2a, we can combine the constants. This becomes plus 1, that becomes 2. And that will be your answer for this one. Okay, hopefully everything is clear there. All is clear. For it to be clearer, okay, let's have more examples. Okay, so given f of x equals x squared plus 2x minus 1. So we will evaluate all x's at 2a. Okay, all x's at 2a. So x is equal to 2a. So all x is here, this x, and this x will become 2a. So f of 2a will be all x's becoming 2a. Okay, so 2a squared plus 2 times 2a minus 1. So all these 2a's came from the x, as clearly seen above. This x becomes this x becomes this. Okay, and this will leave us to simplify things. Okay, 2a squared is just 2a times 2a. That's going to become 4a squared. Okay, 2 times 2a is going to give us 4a minus 1. Copy it. We will not do anything with this minus 1, just copy it. And then combine like terms more, we cannot. These are not like terms again, they don't have the same degree. And yeah, that's our answer for this example. Okay, last, for this prerequisite, evaluate at x equals k squared for this f of x. So everything will be k squared. Okay, so this x will become k squared. This x will become k squared. So we will have f of k squared is going to become k squared squared, okay, plus 2 times k squared minus 1. So k squared, that's a power of a power law in our exponents, in our laws of exponents. So a power of a power, we just need to, multiply those exponents. So 2 times 2 is going to give us 4. Here we have it. We are not going to do anything here except multiplying the coefficients. That's going to become 2k squared minus 1. Okay, that will be our final answer for this. Okay, so hopefully everything is okay now with evaluating functions with variables, not numbers, but variables, just like this one, or groups of variables, shall we say. Okay, now I think we're ready for the composition of functions now. Okay, so the things that we have done a while ago are really similar to what we'll be doing in the composition of functions actually. So let's define composition of functions. Okay, so let f and g be functions. The composition of functions g with f, denoted by this symbols, and is read by g circle f. So everybody, g circle f. Okay, so this is a new function resulted by performing f first and then performing g on the result of f. So we're going to do f first. After we do f, we're going to put whatever is the result on our f function and plug it in, substitute it in our g function. Okay, so I think to make it clearer, or I don't know if this becomes clearer, but g circle f of x is equal to g of f of x. Okay. Anyways, some books call this of. Okay, so you might call this g of f of x, but just call it circle because seldom the word of is used for multiplication. So to erase the vagueness of it, so g circle f of x. So let's try to ponder on this right hand side for a while. So g is a function, so you could imagine g of x, but this time the x is substituted by f of x, another function. Meaning, if we have a g of x, we're going to substitute the values of our f of x in that g of x. Did you get it? Again, we're going to substitute the values of f of x. Okay, whatever f of x is, plug it in our g of x. So to give you a better picture of it, let's have some examples of it. Okay, for example, given number 1, f of x equals x minus 1. That's the value of our f of x. G of x equals x squared plus x minus 1. Okay, so we will be to find g circle f of x equals g of f of x. This one will just serve as a formula. Okay, so what are we going to do? Again, get the value of f of x, and here it is. It's x minus 1. Plug in this f of x to every x in the g of x. How many x's do we have in g of x? 2. This one and this one. This one will become f of x. This one will become f of x. Are we clear with that? Okay, so what is f of x? X minus 1. Meaning, this x here will become x minus 1. This x here will become x minus 1. Because that's the value of f of x. And we're asked to evaluate g of x by or at f of x. So to give you the next line, this will be this. So imagine this x minus 1's inside the parentheses as x's. That will give you g of x, the original one. But we evaluated it at f of x. What's the value of f of x? It's x minus 1. So meaning, every x here will become x minus 1. So this is our next line then. Okay, simply what we did here is all x's here became x minus 1. That is also where and why parentheses are practical. It makes everything clear that this x minus 1 is the original x. This x minus 1 is the original x because it's enclosed in a parentheses. Okay, so that's our number 1. Okay, and then that's composition. One function is composed by another. That's why it's called composition of functions. Okay, so one function is composed of another. Okay, and then after this step is done, after the composition is done, it is up to us to simplify things and then arrive at the final answer. Okay, so we can't do anything with this one. We can just, erase the parentheses here. But here, okay, it's enclosed in a parenthesis being squared. Okay, so remember our routine in doing here. So we're going to square the first term, multiply. Our middle term will be multiplying the two terms, x and minus 1, then multiply by 2, and then squaring the last term. Okay, that will be x squared minus 2x, that's 2 times x times negative 1. So negative 2x, and then negative 1 times negative 1 is going to become positive 1. Okay, copy, copy. Okay, this is where we're going to combine like terms. So let's try to investigate. Is there any like terms for x squared? None. There's no other x squared here. Is there any like terms for negative 2x? Yes, it's here. That's plus 1. That's plus 1. So negative 2x plus 1 is going to give us 1x. Or rather, negative 1x. Okay, negative 1x. Okay, and then the constants, 1 minus 1, that's going to become 0. Minus 1, that's the one left. So that's our answer. Okay, x squared minus x minus 1. And that's our final answer here. Okay, x squared minus x minus 1. Hopefully you got it in this example. I have 4 more, so don't worry. I read it a lot of examples actually. So the key step here is actually this one. Okay, this is the key step. The moment you arrive here, you arrive correctly here, everything will be the same algebra manipulation, algebra techniques. But this one is the most important thing. This is the concept that we're studying right now. Okay, the composition of functions. Number 2, let's have another given. For the f of x, that's x squared. For the g of x, that's 3x plus 2x plus 2. Okay, we're going to be doing the g circle f of x, or the g of f of x. Again, all the x's in g of x will become f of x. So this x here will become f of x. This x here will become f of x. What is that f of x? That is x squared. So meaning this x here, this sole x here, is gonna become x squared. This sole x here is gonna become x squared. That will give us the next line. This one. Okay, enclosed in the parentheses are the f of x's. That is x squared. Okay, so imagine this, everything in the parentheses to be x. That's gonna give you the original g of x. But if we're going to substitute f of x is there, it will become x squared. Okay, let's do the maths. Okay, so what are we going to do with this first term? By our groupings, exponents, the GEM-DAS rule, groupings, exponents, multiplication, division, and then addition, subtraction. So before we could even multiply this, we need to raise it up first to the power of 2. So x squared by the power of a power law in our exponents, it's going to become x to the 4th. Okay, and then this becomes 2 times x squared. It's going to become 2x squared. So just multiplying the coefficients plus 2. Copy this one. Okay, now we're done with our power to power law. We're going to multiply this by 3 and x to the 4th. That's going to give us 3x to the 4th plus 2x squared plus 2. Again, always remember that GEM-DAS law that you have in high school, or the PEMDAS law in some. Okay, and otherwise it doesn't matter. The thing is, the first thing that you need to do is the groupings first, or the parentheses. That's why it's called PEMDAS, parentheses, and then exponents, and then multiplication, division. Imagine if we have done multiplication first here. That will be devastating. Okay, 3 times x squared is 3x squared. Raise it up. This 3 would have become 9 because we squared it, and that's very wrong. Okay, that's just utterly wrong. Okay, so that's our number 2 answer. Okay, for number 3, given f of x equals x cubed minus x squared plus x minus 1, g of x is equal to 2x, and then we're going to find another one, f circle g of x. Okay, so just take note, ordering in the composition will give you, or will lead you to another one. Okay, to another type of formalization. So this f circle g of x is not the same with g circle f of x. If we're going to compare and contrast, g circle f of x, the g is the second this form, the f became first. Okay, so what happened here is that now f of x is our outer function. G of x is the inner function, the one that we're going to do substitute first. Meaning, f of x here, everything here in the f of x, all the x's here will become g of x. This will become g of x, this will become g of x, this will become g of x. So, and what is g of x? That's 2x. Okay, so this will become 2x, this will become 2x, this will become 2x, and then voila, this will be our next line. All the x's in f of x became 2x. Hopefully that is clear to you now. Then we are to continue the simplification. 2x cubed. We cube this 2, that's gonna become 8. Cube this x, that's become x cubed, and so on. Okay, 2x squared. Square this 2, that's 4. Square this x, that's x squared, right? And then 2x copy, and then minus 1 ditto. Okay, and then we should combine like terms if we can. Since we cannot, that will be our final answer. Okay, and that's number 3. Hopefully you got it right. Number 4. F of x equals 2x squared plus 3x minus 4. G of x is equal to 2x minus 1. Okay, and then we will be asked to do f circle g of x. That's f of g of x. Okay, so meaning all x's in this f of x will become g of x. The same with the previous one. So this x here will become g of x, this x here will become g of x, but our g of x difficulty became a little bit higher. This x here will not become another different variable, but this will become a binomial, which is 2x minus 1. This will become a binomial, which is 2x minus 1, which will be in this form over here. And let's do this slowly. Okay, well, this is the original x, this is the original x, and then we substituted both of these x's by 2x minus 1. Okay, again, Gemda's rule. Do the exponentiation first before we do the multiplication. Okay, so if we're going to exponentiate this, or if we're going to square this, square the first term, twice the product of the first and the last term, square the last term. That's our formula. So copy the 2 outside. So 2x squared is going to give us 4x squared. 2x times minus 1 is going to give us minus 2x times 2 minus 4x. Negative 1 squared is going to become plus 1. Okay, and then in this form, we just distributed the 3 to both numbers. So 3 times 2x, that's 6x. 3 times minus 1, that's minus 3, and then copy the minus 4 here. Okay, so we're done with the exponentiation. Let's do the distribution of the 2. It's going to give us, multiply this by 2. 8x squared. This is going to become negative 8. This is going to become 2. And then erase the parentheses. And then we can see a straight, clean function here. Okay, and then after that, we will combine like terms. X squared doesn't have any like terms, so we'll just copy it as it is. Negative 8x plus 6x are like terms. So since they don't have the same sign, we're going to proceed to subtraction and then copy the sign of the one with a higher absolute value. So 8x plus 6x is going to give us negative 2x, and then 2 minus 3 is minus 1. Minus 1 minus 4 is going to give us minus 5. And then that will be our answer for number 4 then. Okay, 8x squared minus 2x minus 5. Okay, for our last and final problem in this solution, in this video rather, hopefully you're getting the gist of what composition of functions are now. And now we're only given one function. F of x equals x squared minus 2x. And we're asked to find f circle f of x, or that's f of x. Okay, so this is where we will substitute the function on the function itself. Okay, so meaning this x's here in this function will become x squared minus 2x. Are you with me? Okay, so this function, the x's of this function will be plugged in by the function itself. Okay, we call this iteration actually. So iteration, we iterate, we do the function and then plug it in again of this previous form. Okay, so circle f of x equals f of x. Okay, so what will happen here is this. Okay, so what happened here? So imagine the ones or the parentheses. Imagine them as x's. Okay, so we have x squared minus 2x, and that's our original f of x. What we did here is we have taken the f of x, this x squared minus 2x, into each of its x's. So the x here became x squared minus 2x, that's the f. The x here became x squared minus 2x, that's f. So we just put the function inside the function itself. So the function is composed by itself, something like that. Okay, you can think of it as like that. Okay, and we'll do the simplification now. This is the key step actually. Okay, after this, everything else is algebraic manipulation or by elementary algebra. So again, this binomial is being squared. Square the first term, twice the product of the first and the second term, square the last term. So we have x to the fourth minus 4x cubed plus 4x squared. Okay, that will be our number here. 4 to the x to the fourth minus 4x cubed plus 4x squared. And then distribute this negative 2 to the both parts of the binomial here. So that's negative 2x squared. That's going to become positive 4x. Because that they're both negative, double negative speaking positive. And then combine like terms. There's no like term for x to the fourth. There's no like term for x cubed, but there is a like term for x squared, and that is just beside it. So 4x squared minus 2x squared is gonna give us 2x squared, and then copy the 4x, and then yeah, that will be our answer then. Okay, so hopefully you understand now composition of functions and how it works. Our key steps are just actually the first lines, and then everything underneath it is just algebraic manipulation and elementary algebra. Okay, so like this video if you want more of this, and then comment, subscribe to our YouTube channel, and like and follow our Facebook page for more. Facebook.com/USLS Math, and then that's it. This will be the end of our composition functions video. Okay, thanks a lot.